Hi, Cedric. Do you know, I think we are not alone. I think we are live. Hi, everyone.
All right,
I see a bunch of people.
Good
Nice to
afternoon,
meet you.
good evening, wherever you are.
Surai, hi, nice to see you. So I think the sound check is good. It's all good. Just can you guys give me a thumbs up if you can hear us well, please?
Yeah, no echo and anything. Hi, everyone. Oh, great energy in the chat already.
Yes. Okay, so, and the count is growing every second. Very good. Okay, so let's start while people can keep joining. So welcome to today's workshop, Introduction to Machine Learning, with Apache Cassandra and Apache Spark. Let me jump to the next slide just to check that there are no strange things here. Okay, so this is
all right. So again, welcome everybody. Let's bring back the energy. So I'm Cedric Lindven. I'm leading the developer advocacy team at DataStax. So I'm a trainer, public speaker, developer, coder. So today we will be together 2 hours live session full of hands-on. Okay, so don't expect a lot of marketing-ish. We are here to code together and do stuff. You will do stuff with us. So yeah, pretty exciting to be there with you. You have my coordinates on the top right-hand corner. You can invite me on Twitter, LinkedIn. Would be happy to have you in my network.
Yeah, and as for me, I'm Stefano. Nice to meet you. Same for me here. I'd be glad to connect to you. I'm a developer. In particular, I use Python and JavaScript, and I like Apache Cassandra and distributed systems. So today we are going to speak about machine learning and how Cassandra and Spark are very good tools for that. And I think a good shout out to all of the team, because today it's the 2 of us, but behind the scenes there is a lot of work to deliver such nice material and such nice workshops to you, and we have to thank the whole team. Here you go. Thank you, team.
Yeah, we will find some folks in the chat as well, helping for
I'm
questions.
sure someone would join in the chat as well. And so very briefly, a bit of information before we start. You are watching us on YouTube, unless we are in the future and you're watching us as a recording on YouTube.
It's
at the
still
same
on YouTube.
Link. So hello, future people watching us. In case YouTube has trouble, which very rarely can happen, you will find us on Twitch, and we will give you the coordinates. I see there is someone saying, hi, all physicists. So I get you are a fellow physicist. Hi. Nice to see other physicists around. Yes, I am guilty to be a physicist, a theoretical physicist in particular. You saw that in the slide. So back to us. We like these workshops to be a lot interactive, which means there are spaces for questions. And in particular, of course, we have the YouTube chat here. But the YouTube chat is for, let's say, questions related to the very moment we are speaking. And anyway, it will disappear when the workshop is over. So please do join us on Discord. You see here the link. Maybe we can ask Nightbot to give us the coordinate. Please join us on Discord so we can keep the discussion going, which is not only about machine learning, not only about Cassandra, but everything developers and admins and everything. So we cover a wide range of topics. That's not the end of the interactivity, because we are also having games and online surveys with you interactively. In particular, we are using Mentimeter. So in a second, we are going to give you the coordinates to join us for the questions. Okay, so let's...
Yeah, and see us up to the end, because in the end, we will play a game using that Menti. And if you answer correctly with the good responses, we will ship you swag to your location for free. So, you know, stay focused, learn with us, and play the game at the end.
Yeah. Very well said. I already gave the link to start joining Menti in
okay.
In the
so
chat.
We told you it will be packed of hands-on, and you don't have to install anything. So we will use database called ASTRA-DB. We will explain you what it is. We will use Gitpod, which is an IDE in the cloud, and we will also you will have all the materials available for free on GitHub. And that means all the slides, all the hands-on, you can reproduce the exercises after the session. Okay, everything's free for you. Yeah, so let's do it. Nothing to install, all web-based.
Yeah. So you will see in the chat in a second also the link to GitHub, but that's for later. So you don't rush to open it. Stay with us. I'm giving that just.
You will have to open quite a few tabs.
Yes. Yeah. So GitHub, and we will run everything in Gitpod. You will see soon what Gitpod is. It's, I have to say, a very cool technology, everything in your browser. And the third piece of technology we're using today is ASTRA-DB, which is, well, it is a database built on Cassandra. More on that later. So let's go on. So we don't repeat ourselves, but ASTRA-DB will be providing the data storage for later, and everything online as a service, easy to use with one click. Okay, so time to move to the goodies, because we don't give a badge of attendance just if you attend this workshop, but there is a small homework at the end, a small assignment, which is hands-on. So we'll have to touch the code and do stuff. And if you submit this, we will be happy to review it and give you a nice badge, which is the one you see here in the slide.
It's a kind of open API standard badge. You can put it on LinkedIn, brag about it. Yeah. So yeah, could be reused later.
Yeah, by the way, this is one of many badges that we have, one per workshop. And I know there are collectors out there. So I don't know, do we have a prize for those who manage to get all badges?
So,
maybe
now overall, we have about 30 sessions. So same format, live, So if you like the format, the experience, the energy, consider to subscribe. Each time you can earn one of these badges. So going over the recordings that you find on this channel, covering a lot of topics, Java, Python, JavaScript, front end, we cover a lot. Yeah, if you want to chase after those badges, gotta catch them all.
Yeah. Okay, so I think it's time for a bit of interactivity now. So please, if you didn't do that yet, open a tab or your phone, go to menti.com and enter this code. And let me reiterate on the YouTube chat. Okay. Okay, so I have to switch tabs here.
So now we will ask you a few questions with Menti. It's not the game. It's just for you to get used to Menti, seeing that it's a live session, see your thing here, and just random questions.
Let me make ourselves a bit smaller so we have a bit more space for the quiz slides. You can also scan this QR code to jump in. And let's see, at the moment we are waiting for people to join. So maybe I'll switch again to this. So maybe, let's see, a bit more. We wait for another minute or so. Okay, so for people to join the quiz. So
okay, yeah, we'll wait. Yeah, just a few seconds for everyone to join. Okay. And yeah, after all this housekeeping, we can dig into it.
Yeah, so just a few seconds. Okay, we are now just asking you a couple of questions to get to know our audience better, if I manage to. Okay, so before starting, just a few questions to get to know you better. Let's see. First, where are you from? So where are you connecting with us from? I see someone more or less in the way of the North Pole. Maybe there's Svalbard there, or Jan Mayen, the Norwegian island, or independent island, I don't know.
Crazy.
Formerly Norwegian. UK, Spain or Portugal, India.
Wow, that's
everywhere in the US, South America. That's
India
cool.
as well. So it must be pretty late for you. So thank you for coming.
Yes, someone even more to the north. I bet you're not just wearing a t-shirt if you're there, especially if you're outside.
Canada, yeah. Oh, wow.
Everywhere. Yeah. That's very cool.
Brexitania.
I see.
Very funny and moon. Okay. All right. Okay.
Okay. So next question. Next question is, what's your experience with machine learning? So are you like, what is machine learning? Or maybe I know the concepts. I see some experience. I use it at work. Very good. Oh, we also have an AI participating, hoping to machine learn something more. That's great. What is machine learning? Yeah, okay. So we have representatives from all answers, I think. Of course, today is an introduction, more focused on practice at that. So don't expect loads of linear algebra or mathematics, just like big lectures. Expect more hands-on practice. So we will be introducing the general ideas, a bit how a few algorithms work, and we will then run them interactively. You will be running them interactively, so very much hands-on focused. So thank you for the answers. Another question, do you use Cassandra and/or ASTRA-DB? I know what it is. That's great. I use it now and then. My daily life depends on it. That's great to hear, What is Cassandra? You will get an answer later. Okay. Cedric, there is a bunch of people whose daily life depends on Cassandra. So that's, let's not screw up.
Oh yeah, no, that would be fine. It's resilient, always on. So it will be fine.
Yeah, you will be highly available. I see. Hi, Aaron. There's Aaron in the chat.
Yeah.
Good.
So him.
Okay. So, okay. Let's.
Do we miss the question?
Oh, I have a very important question. I like to ask this every time. Python scripts or interactive notebooks? This is a, how do you say, divisive question, or how to say that. It sparkles discussions every time, you know, whether scripts or notebooks, there are pros and cons.
And what about you, Stefano? What do you like most?
Well, I am for scripts all the time because I have a personal preference for coding that keeps the structure of the code and does not let you jump back and forth at will. But of course, I have to agree that depends on the task is the considerate answer. And today, for example, what we will do is better done with notebooks. So yeah, at the end, one has to be honest with themselves. Okay, so thank you for the answers. Stay tuned to Menti because we will come back later with more questions and with the quiz. So keep the tab, keep the phone connected, whatever, and maybe it's time to jump back to our presentation. And go. Okay. So slideshow. Okay. Okay, so today's agenda, as you see, is very full, and we have a general introduction about machine learning. Then we will guide you through setting up your environment. Then we will quickly survey what are the tools of the trade, so what technologies are going to be used today. And then we will speak of specific algorithms, clustering algorithms, inference algorithms, and others. And then we will close and wrap up with some conclusion and, of course, the quiz. Okay.
The game.
Yes.
The swag.
The game, the swag, the prizes. Okay, so first chapter. Maybe I try to make myself a bit louder. I get this feedback, so okay. Okay, so machine learning. Cedric, do you want to take from here for this
part? Sure. We can go fairly quickly with machine learning, I think, but let's go. Each time we introduce a new concept, we put back the Wikipedia definition, if you will. But it's kind of a meme because if you read that, it's just super complex, not super easy to follow. And a colleague of us find a way straight to the point definition. I think you can show it now.
There we go.
Yeah, there is. So machine learning in a way, just a science of drawing circle, maybe bar chart as well, and coloring them. Okay, so we will use some algorithm to help us do some decisions based on the data. And this is what we wanted to represent on the next slide with this diagram moving from data. Just waiting. I do have a delay on my end, probably due to YouTube.
Yeah.
Next slide. Yeah, here we go. Okay. So machine learning is a scientific way to process raw data using algorithm to make better decisions. All right. So this is exactly what I said. Oh, look at that. Alex is in the chat. Hi, Alex.
Hi,
so
Alex.
No magic, just billions rows of data in 2 buckets of mathematics and voila. So really start from the data. We need to make some decisions. So classification, clustering, regression, recommendation. So we will pick the proper algorithm, train this algorithm against the data to build what we call a model. And then thanks to this model, we will be able to do those decisions. So what we call predict. So in this huge scope of machine learning, you can find multiple types of algorithm, multiple types of learning, multiple approach. So the first approach is called the supervised learning. You know what you are doing, right? So you have the knowledge of the output. So the algorithm, the model, will learn with the expert. I will show you what an apple look like again and again and again, show you a lot of pictures each time, showing you there is an apple, there is no apple. And when the algorithm learn, it will be able to detect apple or cats in any image. So that's probably the most famous one, supervised one. You really know what you expect. So you train your model and just the model will repeat just what you ask for. The second kind of learning is the other way around, unsupervised learning. So now this time you don't have the knowledge of the output. You want the algorithm to organize the output, sort, predict what should be the output. It's self-guiding. The algorithm will find the group, the classification, the cluster if you wish. You don't have to label the data as an input. This is the algorithm to find what things look alike and group them if this is what you want to do. And today we will see 5 algorithms altogether, and some would be classified as supervised, others unsupervised. You know, it's pretty obvious to realize what you do. Either you provide the input or not. Okay. So let's see what are those algorithms.
There are a lot.
Oh yeah,
just a lot of them.
And you know, it's probably not even close to what you can find. So my goal is not here to read them all, and you know, it's just really a subset. But there are new algorithms every day, and you as a developer, a data scientist, if you wish, I mean, 90% of people here, what you would like to know is, A, what is the use case, what I try to achieve, and what are the existing algorithm I can leverage on. Very few people will actually go and invent new algorithms. It's kind of a research field, I would say now.
Yeah, very specialized even.
Okay, so let's try to organize those algorithms if we wish. On the next slide.
Yeah.
So entry point, I have no idea what I'm doing, but still I know if I do have input or not, right? If I do have input, I will go into the supervised learning category, find a family of algorithms, classification, regressions. If I don't know the output and I want to use unsupervised learning, same here, you see a couple of scenarios. Some scenarios are considered to be semi-supervised, so I guess you provide only a sub-portion of the input, or you do have a two passes on the algorithm, and only on the second pass you will provide data. And also another family called the reinforcement learning, based on the output of your first pass. You will keep improving your model. But for today, the scope will be supervised, unsupervised, and especially those 5 algorithms that you see on screen: classification, regression, clustering, association, dimension reduction. And we pick one of each. Okay, here the purpose is to show you in 2 hours how much you can do, the extension of all the capabilities. So we pick the naive Bayes, random forest, K-mean, FP growth, and collaborative filtering. One notebook for each of those.
Yeah. Okay. So we come to another very important point, I would say. How to tell the quality of a model once you have it, which is not a trivial question.
Oh, not at all, not at all. So you choose one of the algorithm. You provide your data as input. You train your model, and you get what we call a data model, something like an engine that we will keep reusing on new data to do your decision, to do your prediction. And the question is, how good is your data model? How accurate the prediction could be? And this quality characteristic is not an easy one. You know, it's not that easy to define what it is. So here on the next slide, yeah, Stefano, you can go here. We provide you very, very simple, like on 100 people. So we evaluating how much have a very bad cancer, malignant tumor, and who are healthy, who are just benign tumor. And there are 4 type of outputs you can have, you know, like true positive. The algorithm tell us it's a malignant tumor, okay, and it's a true positive. It can be a true negative, so the model predict benign. It could be a false positive, so the model predict that it's malignant, but it's not. And it could be a false negative, and that's the worst, because you are stating that the guy does not have a malignant tumor, and still it does. Okay, so TP true positive, FP false positive, FN false negative, and TN true negative. We can show them as here a 4-box table, or also here with this circle, depending on the matrix we will show you. You can use one or the other. And now let's see the 3. I mean, we will show you 3. There are even more, but let's talk about the 3 main metrics.
Just a remark, the form of the table on the left is, in a sense, the best way to express, because it can be generalized to models where the outcome is non-binary. So that maybe there are 3 different outcomes. You can have a 3x3 matrix, which is called confusion matrix. And qualitatively, you can imagine that a better model is the one with higher counts on the diagonal and lower counts off diagonal, because every count that goes off the diagonal means that the model and the reality have a mismatch. So ideally, you want your model to give a confusion matrix that is only diagonal, zeros everywhere else. And in the case of these yes-no models, which is very common, there are other ways to express it, like these Venn diagrams, and that's great. Okay, so I go to the next slide.
Yeah, so first definition is what we call accuracy. So the definition is really you take as a numerator the correct prediction. So the true positive plus the true negative, so something that you do great, divided by the sum of all the prediction. Okay, so let's play a game. So in the chat, who will be the first one here to give me what is the accuracy of our current model based on the formula? We told you it will be interactive.
Yeah. Let's see. So what is the accuracy of this model? How many correct predictions are there? Okay. 0, 1. Okay, I think we have a winner.
Yeah, I think,
we have Santiago.
We have the so multiple times, so I think you can switch to the next slide.
The solution is here. Yes.
So the solution is here. So the accuracy is everything's correct. So true positive plus true negative divided by everything. So everything now is 100 in our simplified model. And what was correct? True positive 1, true negative 90.
Yeah.
So the accuracy is 91. So you might expect, wow, 91%. That's just
great.
an amazing data model, right?
Yes.
We will save the world with that. Well, the issue is, if you look at the false negative, we kind of we do have an issue here, because 9 people get the very bad diagnostic. You know, they are very sick, and we were not really able to predict that.
Yes.
So let's see if on the data model we have others metric that we should look at.
So I'll go to the next slide. The point is that a model accuracy is how often the model gets it right. But that's really, I mean, imagine there is a very rare case of bad tumor. So a model that always says no will be already very good in this metric. Just says always no, because the positive is very uncommon. So it's all good, right? As an extreme case, that's why there are other metrics. for example, precision.
Yeah, so precision, and better is ready to use the formula here. Count the true positive out of all the positive. So true positive, TP, divided by all the positive. So true positive and false positive. So it's assess how your positive answer are, right? If you are too positive or not. So same question here. Can you compute the precision of this model? I put back the numbers here, 11890.
Yeah, so I see answers are coming in, 05, 05. So
Yes,
precision,
exactly.
yes.
And it's not as good, right?
Yeah.
50% now, so you can throw a coin and get the same precision.
Yeah.
So this model is not as good as it seems to be,
It's
right?
as good in this sense, it is as good as random, right? So precision answers the question, how often a positive by the model is really a positive? And this happens half of the time. That's really not so good.
Yes. And last but not least, and in this medicine diagnostic, I've read that is probably the one that should be the most look at. It's called the recall. Yeah. So this time, the recall will identify the positive out of all the real positives. So true positive divided by true positive and false negative. So that's how good your algorithm behave here.
Yeah. So recall says how many of the really positive are found. What is the fraction of the really positive that are actually found? And if this number is low, then your model does not do the one thing that it's supposed to do.
Yes. Okay, so
I see answers. Very good. I see answers and 1/9. That's correct.
Yes, that's correct. Okay, so to be fair, when you do have this model, that's better to compute all these metrics. Precision and recall tends to be opposite. You know, the better the precision can be, the recall is getting a bit less good by design. So there are a fourth metric, not really detailed here, called F1, where you combine recall and precision just to reduce the effect that precision and recall go very far one of each other. But yeah, when you have your data model, assess the quality using those metrics.
Yeah. So let's say that accuracy is probably not very useful in general, especially when there is a big skew between positives and negatives in the real world. So that does not capture what you probably want to capture. Then you might ask yourself, what is the right metric? The answer is, it depends, because in general, probably I would go for precision out of all of them, but it depends. In this case of the tumor, you probably want to focus on recall, because it's what you want to avoid is to skip a positive and not detect it. So that's the most important thing. But it depends on the case. Let's say you have a data set of your customers and you want to reach some of them for extended interviews, and you want to single out customers with a pattern that signals they are in a big company, let's say. You send them some gifts and everything. So probably in that case, you want to make sure you're not wasting gifts to small company customers. And if you just skip one of those big customers, no big deal. So in that case, you want to go more for precision than recall. And that's really why it depends on the situation you want to analyze. Then, as Cedric says, there are composite metrics that try to balance them, these various metrics. And that's not the end of the story. Indeed, quantifying the goodness of a model is a science in itself. There is something called area under the curve, AUC. And that's a bit of a more complicated metric that tries to measure how better than randomness your model does under variation of thresholds in measuring. So you need a parameter to change. That's when it's available is probably the most refined way, but that's a bit too mathematical for today. So we gloss over and we go to another very important point.
Okay. Another things to consider, before going to those implementation is the fitting of your model. So it could be underfitted. So here you have 3 diagrams, and through a regression you try to find a path that's come the closest to all those points, and you can be underfitted. So not enough precision. You can see that the distance between your line and the points is not the greatest. So not a model I will trust. A good fit is that in middle balance, your line tips to stick to the points, but have still a natural behavior. Overfitted is probably you maybe train your model too much, is too stuck to your data, work very well with your data set. But then if you try to predict a behavior against new data, because it's overfitted, you might have some weird behavior. Better have these average, like robust and good, than these overfitted that will work well with the trained data, but not new data.
Yeah, overfitting is nasty, and it is when the model stops learning what you want it to learn and just learns to the quirks, the precise rows in your own training set. So the precise very rows that you give the model for training, and it learns to mimic them very well, but then in real life, it just fails. We will see ways to keep this under control in a few slides. But first,
okay,
let's do something else for a little while.
Yeah, stop the talking.
And start looking at the architecture, the technologies that power today and maybe your bright future in machine learning. Okay.
All right. I can go quickly. So in a lot of case, you train your data model using some static file, huge CSV file. You extract data coming from somewhere and train the data on that. Today we will use directly the OLTP database called Apache Cassandra. So already organizing the data as table, very fitted for scarce data and very large amount of data. So fit very well these training. So that will be a web-based database. And for the machine learning, that would be the gold tools that everybody using, right? So Jupyter notebooks using some Python with the Python library Spark, and to help the interaction with the ASTRA database, we have created a couple of scripts. So all these CLI, CQLS, CQLSH, so Cassandra Query Language Shell and dsBulk will not very be visible for you. That will be script running under the hood, but just for you to know they are there. They will be used to load the data in the database or set up things.
Yeah, and of course, if you are curious, you can inspect the scripts in the repo and find out all the internals. It's a repo, so you can look at it. Okay.
Okay, so let's have a look first at the data layer.
Yeah. Which means Cassandra, right?
Oh yeah. So, you might not know, but, here we are on DataStax developer channel, and DataStax is really supportive about the open source NoSQL database called Apache Cassandra. So we provide support for that. So what's cool with Cassandra? So it's a NoSQL distributed database, big data ready. You need more capacity or throughput, simply add new nodes. It will scale linearly. There is a dedicated read and write performance per node, and so you can scale. The data is replicated among multiple nodes, even multiple regions. So you can lose any of the data, any of the nodes, it's not a big deal. The database will self-heal. Data could be geographic it could be distributed geographically. Like that, you have your data very close to your app. You're interacting with the node close to you, and Cassandra will replicate the data synchronously up to the other nodes. It's open source, Apache license, so vendor agnostic. So yeah, we are using only open source technology today.
Yeah, so for example, well, I can imagine some of our attendees are asking themselves, wait, should I install a big super mega database over several machines just for playing a bit with data today? Later there will be the answer. The answer is no, it's all ready, but we have a few slides on how Cassandra works.
Yeah, this slide quickly. So as I told you already, in Cassandra, the data is organized as tables. So, pretty nice to train a model. You can have very, very large amount of data in a single table. So again, very good to have a lot of data to train. But it's not magic. With so many rows in a table, those rows will be distributed among the nodes. So next slide, just showing you that even in this kind of 20 record table, the data is distributing among those nodes. And those are grouped by what we call the partition key. Here it is in bold on the schema. So based on the value on the first column, data will be grouped there. So if you can design your table in a way that will fit your model, you will be good. So probably as a partition key, you would like to get your target vector, right? The value of the target vector, just to have the same data set that will predict the same output in the same node eventually. But generally speaking, when we talk about Cassandra, we say you need to design your table that fits your queries, your requests, and you group together what you're supposed to retrieve together. Also, a neat thing, it's kind of almost free to add a new column on the contrary of relational. So very good for scarce model. So we told you it's scale, and we put that slide that Stefano showed to you just to see that the famous guy in the field are the guy like Apple, Netflix, Huawei, Alibaba, and those have thousands and thousands of nodes in their cluster. So 30 million operations per second. So good to train, but also probably also good to predict with such low latency OLTP database and so much data. So even your online data set could be used to predict.
Yeah, a lot of data. So you have to install all of these today on your machine to do the practice machine learning tasks of today? No.
No. So Cassandra, especially because it's a distributed system, take some time to install. But here we have you covered. We have a cloud service called ASTRA that will run Cassandra for us today. Okay, and there is a free tier. You register for free, and you can have up to 40 million requests per month without any issue. You get all the credits to do so.
Okay, so I see a question by Aman. There is nothing to install today. You will do everything from your browser.
Yep.
In a second, I will guide you through all of it. The only thing you have to create your database instance in ASTRA, and then you're good to go.
Yes.
Okay, so
let's move. I think
maybe we can.
Yeah, you have the PDF. Just all the PDF and all the slide exercises are on GitHub. Keep thinking about that. So here we just put back some. Yeah, that's cool. Astra service is cool because super easy to start running for free, and you don't have to install anything.
Yeah, and it can be very well used with machine learning tasks as the data storage behind that. But maybe we can move on to the hands-on. And we start with the first part of today's hands-on, which is creating the database. Okay, so you see the link in in the chat, in the YouTube chat. Okay, so there is, thank you, Cedric. There is a link to go and register your database. Maybe I can quickly show you. So if you click on the link to register the database, you will see a window similar to this one to sign up and create your account. You can use GitHub, Google, or username password to just create your free account. Nothing else asked other than your login. And once you are in,
yes,
I will show you in a second. While you fill this, I will just show you that we also have a repository here, which is, well, this is your reference point for anything, especially if you are on your own later and you want to do the practice or go back to review what happens and everything. So you see there are links to the full steps that we are doing today, plus more, because you see slides, reference to other.
Yeah, exactly. If you feel lost, that's where you need to go. Yeah. If you watch the recording, just pause the video, go there and do at your own pace. Maybe at some point we will be a bit fast, cannot follow and do the step at the same time with us. Totally fine. Those are free, and you can come back later to complete. If you feel it's moving too fast, probably just stop what you are doing and just getting the most of the live session, asking question, and going back to do the homework anyway, where you will have a lot of time.
Yes, so there's no precise deadline for submitting the homework. Anyway, to create the AstraDB, you can also click this orange button, and maybe I better show you. Of course, I already do have an account, so let me.
So when you sign in, you will be asked a few questions. It will only be there once. Okay, so just for us to know who's using that service
Okay, so now I'm logging in, and this dashboard you see is similar to the one you see after logging in, except of course I already do have two databases because I do my secret stuff already, but that's secondary. Okay, so Virai, I see your questions. I will be there in a second, but I want to be giving clear explanations for everyone. Whether you just created your account or you already have an Astra account, you can create a database, either because you already see the create database prompt, or you can click this button, create database here, or create serverless database here on the right. That's the same. Okay, so all these instructions are in the GitHub repository, because when you create a database, you will be asked a few details of this database. And you see it's all here, database name, key space, and regions. Now, bear with me. I'm creating my database, and I will call it workshops. I'm creating a key space within this database. A key space, well, let's say it's a group of tables. So it's a bit more, but let's say it's a group of tables, and we call it machine_learning. Then we have to decide where in the world this database will be hosted, because that will live in the cloud managed by AstraDB. I suggest you to stick to the Google Cloud, which is available to the free plan. Yes. Then choose whatever is close to you or whatever you prefer. So I'm in Europe, so I'll go for this one. You see some of the regions are have to be unlocked. That's because we are on the free plan.
Yeah, so, pick some region with
those.
With no locker. Yeah.
So no padlock sign next to your region. So database name, workshops, key space name, machine learning, and then you choose whatever region is available to you within GCP, possibly. And now I click create database. Now the cool thing is that this is now being created for you. You just have to wait a couple of minutes or so while the database is being created. And you see here, you can track the status of the creation, which would take 2-3 minutes most. But in the meantime, something very important happens. While the database is being finalized, you will be given these very important token. You see, well, you probably don't see because it's all dots. So let me make it visible. This token is your way to get in your database, because since it's in the cloud, you need some security in place. And this is the credential you will use to connect. So let me copy this token. And you can also download it. Sorry.
Yes. For security reason, this token will be shown to you right now and not after all. Later, you can create new tokens if you wish. But for this one, make sure you copy paste on a notebook, notepad, somewhere on your machine, or just download the CSV that clicking download token details. You will have to copy paste client ID and client secret.
Yes, so you see, I've copied my token. Well, I probably would save it to a file, but this is for today's demo. So I copied my token here in a notepad, whatever, and I'll keep it ready for later. In the meantime, my database is active. That's great. If you don't save it, Aman, you will make sure you have copied it somewhere else, because it will not be accessing, you will not be able to see the token anymore. You will create a new one when you need, but you better save it or store it somewhere under your control, because it's a secret, not to be shared. Okay, so you can now go to database.
It's active.
Yes,
nice.
It's been active.
Okay.
Maybe we can ask in the chat to give a thumbs up if your database is active and if you manage to get your database and your token, just to make sure everyone is with us.
Yeah, this is also, as the database take a minute to start, it's also good to start by the database and then start the rest of the tools.
Yeah. So where to find the tokens? The tokens, Florian, you should have seen them when you were creating the database. In case you get to your database, you don't have the tokens. Maybe we can give you instructions to create a token. Let me go for them very quickly while we wait, because we have a wiki called Awesome Astra with also information on how to create a token on an existing.
I shared the instruction I shared the instruction to Viraj a few moments before, but
thank you.
If you need to create a new token, this is appreciated.
Okay. So I see a lot of people have their database, and I think we can move on. Okay, so you have a database empty, of course. There's nothing yet there, not for long. You have your database and you have your token. Now, what happens now? You need, well, we start the setup, or maybe we get the bundle. Let's do things in the right order. We need another piece of information to connect to the database from the code. And we need something called a secure bundle. This is a file that you will give to the drivers to talk to Cassandra, to AstraDB. This is a file containing information such as proxy information, certificates, and stuff. You just don't care. You just give this file to the drivers, and it will know how to use it to establish the connection. To get this file, you see I am in the dashboard of my workshops database. Here, you see these tabs here? Head to the tab called Connect, here, the third one. So I'm clicking on the Connect tab here. So, and what you see now is a page with information on the very many ways to connect to your database and use it. Now, the only thing we are interested in now is in the Connect tab, choose whatever, Python. You see Connect using a driver here. You go to Python. And this is the page about the various ways to have Python speak to your database. What we need is the bundle. So you see this blue button here, download bundle. And there we go. So I'm doing that again. I am in the dashboard for my workshop database. Look for the tab called Connect. And look for the Python connection here in the various ways to connect. Now this page will give you the chance to download bundle. There we go. You click to this and you get, you see, maybe it's too small to see, but it's called Secure Connect Workshops.zip. Luckily, I already have my file browser here, and maybe I can try to make it bigger. There's no way. Don't know how to do. But here you see the file I downloaded. Very small, but it's called Secure Connect Workshops.zip. We will use it in a second. Let's go back to the repo for step 5. Cedric, we covered this part also now in this demo, right? In this part of the demo, we go up to having the Jupyter up and running. Yes, let's do that.
Maybe, yeah. Let's
so
do
we
this.
have everyone has the bundle ready, and we get it done to the end.
Yes. Let's have the That's the best.
Okay.
You download the zip and you will use the zip immediately. Yes, I think that's best.
Okay, so it's time to start your Gitpod. But you know, we have a few slides on Gitpod, so maybe we can wait a second at this point to give time everyone to get their bundle. We do have a few slides on Gitpod, right?
We do have a few slides on Gitpod.
So let's
this is what I was thinking. Should we show those slides? But
so to give everyone time to make sure they have the database, the bundle, and the token, I'll go back to the slides before we do the Gitpod part. So
yes, we put back a few slides to give everyone the time to proceed to these steps.
Yes. So something about the tools that we will use today.
Let me also answer to Florian.
Okay.
With you know, now we have some wiki, and we explain step by step how to do X, Y, and Z. Okay. So
sorry, just a thing. There is a recurring question. What do you do after getting the zip file? You don't unzip it. You keep it as a zip, as a single file, as a single archive, and you keep it there. We will be uploading it in a second to Gitpod. Just keep it there for later. Okay?
Yes. So yeah. So when you downloaded the zip, you catch up. Just wait. We will keep going in a moment. Okay. So next slide, I think. Can move on. Yeah. So it's coming. Right. So you don't have to install anything. And that's due to the magic of a tool called Gitpod. Gitpod is VS Code in the cloud for free. You can go gitpod.io and you can have there and open a Gitpod environment against any GitHub repo and start coding right there. And in Gitpod, you find Java, Python, Go, and even more tools. And speaking of more tools, if you go to next slide, what we need today is, so that's the Gitpod slide. So ready to code. It's not only to do what we will do today, but you can it can be your new ID if you wish. It's really VS Code in the cloud. So moving on. Yeah. So, all right. So we need Jupyter notebooks. So Jupyter Notebook, the easiest way to have it is to run it as a Docker container. And get what? In Gitpod, you already have Docker Compose ready for you to go. So Docker, just very an overview of Docker on next slide. That's really an engine to run you application in a box. When you execute Docker run something, if a Docker image exists, the Docker image will be downloaded and will run on your machine. So it's a great way to try anything without installing the components. So, you know, as a developer, as a data engineering, this is really something that you should consider. Even on your own laptop, it's always easy to try X, Y, and Z using Docker.
Yes, Docker is a life changer. Yeah.
Okay. All right. So, and we are starting a Docker image, Jupyter notebooks. In this image, Python is already there, Spark is already there, and pip is already there. So you will see in the notebook that we will execute Python code. And the reason is Docker container contain everything we need. And this is how you will execute Python code. It will feel magic, so it's not.
Yes.
Just Python code inside Jupyter, inside Docker, inside GitHub on your browser.
Yeah. So that's a Docker image that was created by the Jupyter team, ready with everything ready there for use, with a bunch of scientific computing and machine learning stuff as well. And I think we tweaked it a bit just to have a few more dependencies for some Python.
Yeah, or
bonus
preload
things
the
to
drivers
run.
to connect to Cassandra, pip install Cassandra maybe, but very, very few stuff.
Yeah. Okay. So, well, maybe I can go on from here. So after all this magic, I see Matthew is amazed at this setup, and you will see how seamless it is if we get to run in it. So on top of all this, we are using Python. Python is a programming language. I bet some of you have heard of it already. It's now there for a lot of years. It's been growing like crazy. It's become almost the standard machine learning language, I would say. There is a very big ecosystem, especially for machine learning, AI tools, but not only that. Yeah, it is a scripting language that has become a real grown-up language year after year. We are now at version 3.10, I think, 3.11 maybe already out. Not sure. Anyway, yeah, so you see here a sample of Python. It's very readable, and it has a quirk. Particular indentation is part of the syntax, which is funny to non-Pythonistas, and it feels so natural if you get used to it. Okay, so we will see Python at work later, so maybe we just move on. I mentioned that Python has a very big ecosystem, especially when it comes to managing data, and Pandas is an example of that. So I'll go very quickly on that, but Pandas is one of the Python libraries I was mentioning, and it is a library to manipulate data, tables, let's say rows by columns kind of things. And in a very seamless way, Pandas is designed to make these boring tasks of juggling data, wrangling data easier. And it is also able to work in place, to work with pointers, so it's pretty fast also at that.
So for today, the data that will be loaded as table matrix, if we will. So the term that we use is really data frame, because this data frame object come with some manipulation of those data set.
Yes. So let's say the most important structure in Pandas is the data frame, which is basically a table with names on the columns, if you want, and filled with data inside in it. You see here an example. We will use them later. That's not the end of it, because we also have pspark. What is pspark? Well, pspark is a Python binding for the underlying Spark engine. What is Spark? I think Cedric mentioned that already. Spark.
Yeah,
sorry, go ahead.
Now, just in the comment. So Sparky is a question engine. So Spark is a galaxy of small pieces. What we'll use today is Spark ML, so Spark machine learning. All the algorithm that we will show you, you won't have to implement them, of course. We will just import the algorithm as a function and use it with proper parameters. So, and you will see how easy it is to integrate with Python. So PySpark, Spark ML will do the magic for us today.
Yeah, even though Spark is written in Scala originally, but due to its popularity, bindings for major languages have been created, and pspark is one of them. So we will see at work later. There is another very important package, well, another couple of them. Very quickly, NumPy is a package for scientific computations in Python. So it does a lot of fancy mathematical things to our data, especially for numbers, but it actually does more. In particular, it is very good at working in a vectorized way. So you have, let's say you have 1,000 numbers and you want to apply the same operation to all of them and get a new list of 1,000 numbers. NumPy is for you. And the cool thing is that the engine is written in compiled languages. So I think it's a mixture of C and assembly maybe also, which makes it very fast. So faster than, of course, what you would get with pure Python. NumPy is used a lot and it's very powerful, especially paired with scikit-learn. So sklearn is an open source tool for, well, let's say machine learning tasks in a broad sense. So it does a lot of machine learning algorithms. It does a lot of data transformation for you. So it is, again, a very high level package built on top of all the goodies within Python, and not only that. And it is irreplaceable companion if you want to tackle machine learning in Python. There is a detail that maybe you will see in the notebooks, but we mentioned that Pandas has data frame, which are its representation of tables of data. PSpark also has its own version of data frames, which have basically the same interface, but they are an abstraction over distributed data, living within the Spark distributed computing context, of course. But from the outside, they look more or less the same, which is very cool. Okay, I think we are ready to go back to
it was a lot
demo.
of tools to present, but you know, now it's behind us, let's use them.
Yes. So maybe I better jump back to the repository because now it's finally time to open Gitpod. I think some of you have done that already, but now look at this part. Maybe these very important Gitpod button is better put in the chat. Please, to open Gitpod, you should right-click or whatever context click you want and do open in new tab. So we can keep the README open, you know. If you open in new tab and you go to this new tab, you will see Gitpod starting. So what does this starting do? A lot of things, actually. It creates a virtual machine for you in the cloud. It clones our repository with everything, and it starts a bunch of stuff. So this is the magic behind the scenes that you see here happening. Basically, within this Gitpod instance, which is in general, it is an IDE and a virtual machine. For now, today, we want to use it just as a machine to run our engine, basically. In this moment, within Gitpod, you probably see in your Gitpod tab, you will see the same as you see here. By the way, you might have been asked to authenticate before starting Gitpod. You can use your GitLab or GitHub credentials just to give your identity and have this start. Which editor to choose, that's really relevant to the point that I am closing the getting started today. So we are not using that. As we speak, Gitpod is frantically, so my Gitpod virtual machine is frantically building my Docker image to start the full goodies that you saw before. So Docker, within Docker, there is the Spark engine and also Jupyter and also the dependencies, Python and everything ready to use. Now, give it another half a minute or so, and you will be asked something by the prompt here. You see, this is an IDE in the cloud with a file editor on the left, a file explorer on the left, an editor on the top, and a terminal like you would have any bash terminal on the bottom. At the moment, the terminal is still running some stuff. And I think we are done, almost done. You see something is happening. Do not worry much about the details. I think in a few seconds, this step will be done. Yeah, I know it takes 2 minutes and more, but you see there is a lot going on. If you are curious, look at the internals and you will be amazed. Okay, here we are. I try to make this a bit bigger, even though maybe that goes a bit against. So, okay. You see, now the script that we created for you is asking to insert some of your information for connecting to ASTRA. And you remember the token? This is the time. I go back to my notebook. I find, you see, client ID. This string is my client ID. And I'm going to paste it here. Control V should work. I paste it here and I just hit enter. Now, enter client secret. Same thing. Go to your token and get the secret. So you see, this is called the client secret, and it is the full string, this one, a bit longer, and you can go here and paste it here. By the way, if you do something wrong in the Gitpod, in the GitHub repository, there are instructions to reset and redo it. So don't worry too much. Okay, now there is a very important step, the bundle file. Please drag and drop the bundle to Jupyter Secure Connect. Okay, so I go retrieve my file explorer here. You see the Secure Connect workshops. Actually, you can just drag it here to Jupyter and then to Secure Connect directory. And if you just drag and drop it, it will be uploaded to your Gitpod. Okay, so you see it's just a drag and drop from your local computer file viewer over to the browser here. You drop it here in the left panel, the file explorer. Okay, so press enter when ready. I think I'm ready. Probably I'm not, but oh no, okay, this is okay, no big deal. Okay, so after that, I am asked to confirm the location of this bundle. It's all right, and I can press enter to confirm. Key space name, machine learning. In case you gave it a different key space name, now it's the moment to write your key space name. Okay.
You know, Stefano, maybe we can pause here a bit. You know,
Yes.
for some people, Gitpod can take 1 minute, even a few minutes to start. And if you go and do all the steps, they could be a bit lost.
Yes, that's right. So we give a bit of time for all Gitpod to start, and it might take, well, in my case, it took a couple of minutes or so to start. It might take a bit more. The important thing is that when all the setup is done, all of the automated provisioning of the Docker part is set up, you will see this AstraDB configuration, and there will be a prompt to enter your client ID and your client secret. You just paste the values from your token, the one you got created in your database. After that, you will have to copy your secure bundle that you should have downloaded back from ASTRA. You copy your secure bundle here. And by copy, I mean you drag and drop the file from your file explorer over to here, Secure Connect, Jupyter Secure Connect. You copy the zip file and you can press enter and resume this setup, which will basically just be confirm the zip file and confirm the key space name. This is it. This is all the information required, and we just wait until another minute or so, but I just show you what happens in the meantime. The script goes on by itself, and it actually does a lot of things because it creates tables and populates those tables with the data, with the rows needed for the machine learning tasks later. So you will see a lot of output such as, oh, I imported so-and-so rows over to this table. I imported so-and-so rows over to this other table, and so on. That will take maybe 1.5 minutes, 2 minutes. Okay. Yes, so maybe I go again. So the part where you have to do something is this part I highlight here. You enter the token client ID, the token client secret, and then you will have to drag and drop your Secure Connect bundle zip file from your machine, from your computer over to Gitpod, which is your virtual machine in the cloud and virtual editor in the cloud. Okay, I see there are some errors.
Yeah, just to provide the path of the secure bundle.
Found workspace workshop. That's very strange.
You know, file not found. I do not see the name of the zip file there.
Yeah, probably this is a missing secure bundle zip.
Yeah, because you know, you see Stefano's screen. At some point, he say enter secure connect bundle location, but he did not really enter anything because the file name was fine.
Yes, that should be the default location that has been detected if you drag and dropped your zip file. Okay. Okay. I see someone got to the opening part. Very good. Okay. So
Nice.
maybe we can. So.
Okay, Aman as well.
Okay.
Yeah, it's just yeah, Rove.
The Jupyter login. Okay, so I see some managed to get everything running. Okay, I think we should go on to copy the client token. You mean from so to copy the client token, you mean from ASTRA. I think I selected the full thing, or maybe there is a clipboard. Yeah, there should be a clipboard icon. Okay, so the easy thing is to copy the token information as your database is being created, because then you just happen to have it there for copying. Otherwise, you have to go to create a token yourself at a second time as a separate operation. I think I will just, I don't know, set it. Maybe we, okay, so if paste does not work in Gitpod, you can try Control V. If this doesn't work, you can try, yeah. So this is, I know it's a Gitpod problem. If Control V does not work.
Fast, the first time you might have some warning message on the navigation bar, and just asking you to allow to paste inside Gitpod.
Someone suggests Control Shift V, that might work. Actually, this depends on the combination of your operating system and your browser. So we know it's a bit different, but if Control V does not work, maybe Control Shift V or right click. Yeah, so in my case, right click does not work. I'm on Firefox and Windows, by the way, but this is really couldn't seem to paste in Safari. Chrome works well. Well, this is password. That's funny. Okay. Okay, so Matthew, thank you for this. Max seemed to unzip the bundle automatically. That's weird. Okay. I suggest we go on and we sadly give instructions for those having problem. You see, there is a
yeah, I you know also, you know, Zof Zakaria got the issue. So if you, I don't know, did not correctly enter the client ID or client secret or the secure bundle, you can always execute setup.sh just to re-enter them.
So if you have some problem with the setup of your database credentials and similar, here there's a small set of instructions on which script does what, so you can look at them and restart them manually. But now I think it's time to move on a bit. For those who already got to the point of having the environment working. So
yes, and Bastard Bora was asking how to open the notebook. So.
Yes, so the notebook is supposed in principle to open itself in a new tab, but I guess everyone has a pop-up blocker. So you see, please check your pop-up blocker. In my case, I can just go to here, options, and unblock these URL. But in the worst case, you see there is a target URL printed at the end of the script. You can just take this, copy it, and open manually in a new tab. And there you go. So you see there is key space should be machine_learning if you were sticking to the instructions. Otherwise, this depends on what key space you entered when you created your database. Probably is machine learning. Okay. Okay, so one way or the other, let's assume you managed to open the tab containing your notebook. So now, to reiterate.
Yeah, I'm helping as much as I can. So
okay,
yeah.
Thank you, sir. Yeah, I think this part depends really, Control-V and stuff, it depends on your particular setup, your operating system, your browser. So it's very hard to get everyone, to give everyone the help. But of course, we will be, please contact us later or look closely at the instruction or just scrap your Gitpod and restart it again from scratch. We will be happy to help each and every one of you. So at the moment, I'll go forward to show what comes next, which is the cool part. So this is the notebook interface running and using the server, which is running within Docker, which is running within Gitpod, which is visible in your browser. Oh, everything clear? Very good. So to unlock access to Jupyter, you need a password. And I wrote it wrong. Yes. So the password is luckily found in the instructions, and it is ML rules. So I paste these here, just ML rules is the password. Once you enter the password, you can finally see the very, I guess, familiar to many of you Jupyter interface. Finally, we are here. And we can actually have a look at all these notebooks. But before doing that, I think we can spend a little time on the algorithms, just for you to know what they are and which use cases they cover. Okay, so I think this part we will be doing as an overview. Cedric, what do you think? 20 now?
Yeah, go.
Okay.
I mean,
so in machine learning, especially when it comes to supervised learning, there is a very standard procedure, I would say, which starts from the raw data and goes all the way to having the final model that you will like to use in production. So you see, there are a few steps outlined here, but maybe I'll just just go to the sequence of them. So the first thing is you have some raw data. Let's say you collect data out there in the wild, and they are probably not in the format you need. And maybe there are a few odd entries, there are a few nulls here and there are irregularities in the format, and all these real-life things. So a first task, usually seen as a very boring task, is cleaning the data, changing its formulation, changing the format, reshuffling, and maybe getting rid of unwanted rows, such as null results or stuff like that. So let's say the cleaning is the step from the raw data to having a cleanly prepared data set ready to be used to train your machine learning models. In particular, one speaks of features and labels. Basically, features are a neat way to present the input data. So every item you want to, let's say, classify will have a set of features, usually numbers. Maybe they are arranged in a vector, in a list of some kind, one per row, one per item. And you have labels. Labels are the thing that the machine learning model is supposed to guess correctly. But of course, in your initial training data, you will have labels to train the model. Now you do a very important thing. You split the data. Now let's say the most important thing is to split between training and testing. That's because if you remember overfitting. Overfitting is when your model starts to learn the precise rows you are giving it training, and it doesn't learn the problem anymore. It just learns to behave correctly with these input. That's not good because then it's a useless model. So to make sure you avoid this problem, you divide your input set in two parts so that you train it with a part of the data and you test it with an independent part, an independent set of input rows. So if you have overfitting, you will see a very good performance on the training data, but then a very bad performance on the test data. And then you know it's overfitting and it's not good. So this is a way to keep overfitting under control. Then in the best practice, you will also split the input data in three parts. That's in particular, so the validating set being the new part. And that's in particular when you have, when you want to choose between different models. So let's say you train the models on the training set. Then you use the validating set to compare the performance of the various models. Once you decide your best model, you stick with that one and you retrain it more with a full training and validating, and then you use the testing set to evaluate the performance, the final answer for the model. Now, the important thing is that these 3 or 2 parts of the splitting are independent. They do not overlap. Otherwise, you are sort of defeating the point of the train-test split, and you're at risk of overfitting. Okay. Well, I think I spoke about all these steps. Now, a small intermezzo, when you hear training the machine, you might think of a machine in the gym. That's just for fun. That's because a few days ago, a nice machine learning model was released to the public. And the fact is that this image was created by the model starting from a text input. So I put a metallic cyborg in a gym and I got this image back. So this is a pretty funny...
You can play with it. I share the link.
Yeah, it's in the
slides. It's pretty busy. You might need to retry multiple times before getting your request through.
Yeah,
but you can put whatever you like. I mean, yes. I saw Stefano, ask for a frog on a skateboard in a river, and that stuff was quite amazing.
So it is not infinitely powerful, but it's still funny. And of course, well, this is an advanced state-of-the-art research kind of machine learning. This is not what we are going to do today, but it's funny. So back to us. So validating to tune and to compare the various models. And then with the testing set, you do the final assessment of the performance of your model by evaluating the metrics we were talking about before. So recall, precision, and so on. Okay, so you have your model, and now you want to go to the final, to use the model. Everything that you have seen so far was done, let's say, by data scientists in the back of their house with their laptop or whatever kind of resources they had. But now that the model is done, that's probably where production usage starts. So this final model is going to be deployed somewhere in production, and it will be constantly receiving new data in the form of features, and it will be giving out predictions in the form of labels. So this step is called prediction, and that's not necessarily something about the future, but it's prediction because the model does not know the actual labels. It just tries to guess them, and hopefully it will do that correctly most of the time, according to your metrics. So the final model will just have input as features, and it will be giving out labels, maybe with some probabilities associated to it. It depends on the model. Okay, so that's it for maybe Cedric, we can skip that.
Yes, this is what I was.
Okay.
I propose to skip that demo. Let me copy paste that URL for everyone as well, if they want to. But yeah, let's skip.
Okay, so the first model we are going to run is k-means. Well, maybe I will just show the demo just as a way to.
Yeah.
So
okay.
K-means is a clustering algorithm. What is a clustering algorithm? You have a set of points, which might be a set of entries in a list. Let's say you have customers and you have numbers associated to each customer. So your features might be time spent in the shop and amount paid, and maybe, I don't know, how many aisles they visited during the shop, whatever, and you want to find groups of similar users. More mathematically, you have points in a space, let's say a two-dimensional space like here, and you want to find groups of points that are next to each other. So for example, in this case, you have points, and you give the algorithm as input the number of groups or clusters you want to get. So that's very important. It is an unsupervised algorithm. You do not give labels. You just give the bunch of points to the algorithm, and you ask it, please find groups of points that are close to each other. And in this case, so basically what happens, so this is the demo Cedric has put the link to. The algorithm starts by placing these initial seeds arbitrarily, randomly, and somewhere in the plane, and then with a number of iterations, the points move in a way that minimizes the skew. Let's say every point moves in a direction where every point moves iteration after iteration so that it is more in the middle, in the center of mass of its point, in the middle point of its points. And eventually, there will be nothing to do anymore, and this will be the final answer. But you see the funny thing. So if I start with a different placement of the seeds, the final result is again the same. That's because that's because the algorithm works very well. But still, there are two limitations of this algorithm. One is that you have to provide the number of clusters you want to get. So if you look at this distribution, okay, now just look at the small points. To my eye, this is naturally 4 groups. So if I ask for 3 clusters, then I will get a purple one, a blue one, but then this red one will be really just 2 clusters put together. And this is something the algorithm does not know. So if I ask for a 4th cluster, maybe it might be that the algorithm captures what seems natural to me, like this. But there is also a hidden dependency on the initial location of the seeds. So if you start like this, you see it will be not the optimal choice. So the algorithm has converged, and I found 4 clusters, but this is a bit of an unnatural choice. So there is the risk of getting stuck in a local minimum, so to speak, and not to capture the most natural grouping. That being said, this algorithm is in general very powerful, and it has a lot of applications in real life, such as this grouping customers depending on their shopping pattern or whatever. That's why the first demo here, the first algorithm we are going to run is k-means clustering. And to do that, you just go back to your Jupyter notebook here and you click on one k-means. If you click on this, you will see the Jupyter interface. So for those who do not know this yet, you are running Python code. So you're running code, but in a step-by-step way. So okay, except don't mind the titles and the images, but the point is that you have Python code plus some so-called magic commands like this one, and they are grouped in cells. You see there is a cell with a bunch of imports. We prepared a cell that does some initialization of secrets, reading some secret file. There is a cell that creates this session object and so on. So instead of being a single long script, it is a group of cells. Each cell has Python code. And to execute, so we can run the code cell by cell, and we can stop in the middle and inspect variables. We can go back and rerun a previous cell and all that. So it's what is called interactive computing at its fullest. So it's more than a REPL, no? Okay, so how do you execute the cells? This is important. Click on the cell and you do Shift Enter, like I just did. If you go to the first cell and hit Shift Enter, you will see that there will be an asterisk here in the square brackets on the left during the time the cell is executing, and then it will just bear a number, which is the sequential number the cells have been executed. Okay, I clicked in k-means on Jupyter and I get an error message not found. That's pretty weird. Tulip, I think for some reason you might have stumbled upon a weird Gitpod environment, because that's not the first time you see something strange. Maybe at this point the best thing would be to scrap your Gitpod and recreate it from scratch, hoping for better luck, because it's really strange, this message, right?
Yeah, message not found on clicking a notebook. That's,
I mean, if this page gives you this listing and you can click on it, then the file is supposed to exist. Otherwise, that's very weird. Okay.
yeah, and I don't think there are any permission involved to read those files.
Shouldn't be. Okay, the other works perfectly. That's strange. Okay.
Okay. Oh, that just this one. All right. Okay.
Okay, so maybe you can.
Yes, it is
Yes.
okay to run the notebooks inside
actually,
Gitpod.
I am running them inside Gitpod.
But
okay, sorry. You mean inside the mini browser of Gitpod? That's a bit.
Yes. Yeah. So the point is, at the very end of each notebook, you see an instruction to stop the Spark. And also when you exit one scenario, you should stop before starting the other one.
You should stop completely every notebook before opening the other, because Gitpod has limited resources.
And it's not your power, it's the power of Gitpod. So, you know, even if you are working on an iPad or something, you still have the same power as everybody else. It's on the server side.
Yeah. Okay. So, okay, so maybe I switch back to demo mode so we can keep less real estate on screen. Okay, so let me go through the cells and execute them. Okay, so import. For those familiar with Python, these are just import of a lot of things, in particular PySpark machine learning stuff, and also Cassandra driver to connect to ASTRA and other secondary things. There is also a tool we made to show a data frame, to show the first lines, and there is also a tool to see the structure of Cassandra tables, but those are secondary in a sense. Now, the next cell just reads the secrets file that was created during setup and makes available the information that will be later used to reach the data on your database. So if I shift enter this one, this will just very quickly be executed. Now, a funny thing of notebooks is that while you execute, you can insert new cells anywhere. So if you're not editing, now you see I have a cursor here. If I hit escape, I am in non-editing mode, and I can add a new cell by pressing B. And in this new cell, I can quickly check. I write the name of a variable, hit enter, and I will get an output. So like this, easy. So this is why interactive computing is very good when it comes to interactively executing code. So I have to admit. Okay, so back to us. This is, I'm not going to inspect every line of the code because we are more focused on the general usage, but this is how you connect to Cassandra, to AstraDB in particular. We are passing the credentials to this cluster and then to this connect method to get back a session object. This session variable will contain access to Cassandra, basically. As a check, we can execute this cell here, which does a connectivity test. It just uses the connection to read a standard table, and it will print, if everything works, it will print an output like this one, connected to cluster at data center, and this is just to check that we are actually speaking to our database. Then you set the session to work in a particular key space, which is our machine learning key space. And then if you want to look, you remember the scripts at the beginning that were creating a bunch of tables and putting data in them. So one of the tables is called social media, and this cell will give me a printout of how the table is structured. Well, so briefly speaking, there are a bunch of columns. All of them are numbers. So this table contains a data set about social media posts, including how many reactions, how many said reactions, how many times the social item was shared, and so on. So these are all numbers. Plus, of course, there is a status ID, which is just a unique identifier for every row. And then there is a social type, which can take the value video or text or post, video or image, I don't remember, picture of video here. So the goal is to use k-means clustering to try and tell apart pictures and videos just by looking at the numbers. This is an experiment. Will it work? Will it not work? With which accuracy? These are the questions, right? So in the process of creating a model and testing it, these are the typical questions you're going to ask yourself. And now, the important part. You remember that this container, this Docker container offers Spark available for you. This is how you create a Spark session within Python. So this is using PySpark, and it does a bunch of stuff. In particular, it has to provide connection information to reach Cassandra. And this is how you do that. Again, this is using the same connect bundle client ID and client secret we used to directly connect to the database, but this time these are passed over to Spark session. And once this Spark session is created, we can use the PySpark method to tell, dear Spark, read an object of type Cassandra table, which has this name and lives in this key space, and please load it. And then if I hit enter, this execution will take a few seconds because it has to create all the stuff. But the important thing is that this is happening through Spark. Now, in a real environment, you would have maybe 20 Spark machines, 20 Spark workers running in parallel and reading chunks of your database tables from several servers and doing all the things behind your back up to getting your final number, this count here. Now, in this case, we are playing with a smaller scale Spark, which is a single executor, but still we are using Spark So this is the idiomatic way you would read a table even in a gigantic Spark cluster. Okay, so we know we have so many rows for social media. Now there are a bunch of show commands like this one. You see, this is a sample of the Spark data frame that basically mimics the same structure as the Cassandra table. Photo, video, photo, 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 and so on. Okay. Well, this is nothing so important, but we need a way to convert social type from a string to a number because machine learning models usually work with numbers. And to do that, we have ready-made tools. So string indexer is such an object that will be able to automatically make the conversion. So I just run this part. We create a string indexer and we apply it to creating a new column. And this is it. You see from social type, the column label has been added to my data frame, to my Spark data frame. And 0 and 1 mean photo and video. So the machine learning model will, as usual, will work with numbers. Okay, so maybe this is irrelevant. Now you see every show df takes some time. That's because every show df will be re-triggering execution of a Spark command. Now, if you are just training, probably you would not use all of those show df, and your execution will be a single Spark pipeline that would be as fast as possible. But today we are here to show stuff, how it works. Okay, so this is a command to group the rows by social type and get the counts of them. So we know we have so many video posts and so many photo posts. Okay. Then remember we are doing an exploratory study, so to speak. So we can use pandas and its plotting facilities to get a nice drawing. So here you see we have a number of likes on the x-axis and number of comments on the y-axis, and we scatter plot the points, and we have the luxury of having the label, even though this is just a clustering algorithm. So we can color them in 2 different colors, having, I don't remember, I think pictures are the yellow and the, no, that's the other way around. Picture posts are the purple one and yellow are the video ones. So there is probably some kind of pattern. Now the question is, here, yellow is video, okay. Now the question is, will k-means algorithm be able to find the 2 clusters corresponding to video and pictures? Remember that k-means does not know about labels. This is something that we keep as a secret for ourselves. So this is again a step of taking, we decide to work in the likes comments space, so in the plane. And this assembler, this vector assembler is a facility from PySpark machine learning tools that just takes 2 different columns and make them into a column with a vector, an array of 2 items. So this is not something very profound, but very useful. But now this is the important part. You see, now we create a model of type k-means clustering. We set the number of cluster to 2, and we set a random seed that will be used to place the initial positions. And this is where you fit the model on your training data. So it will take these points as an input and try to find exactly two clusters. Let's see. Then, while it runs, it will be just a few seconds. While it runs, you see, we also make predictions. So we apply the model to the data itself, and we can compare the prediction to the label. You see, 0, 0, 1, 0. This is a wrong prediction. You see, this is a false negative in the parlance we saw before. But of course, this is just a sample of 5 lines, 5 rows. Secretly, we know which posts are pictures and which posts are videos. So we can do a first assessment of how close to each other the counters are. You see, the prediction column gives a lot of zeros and just a few ones, while the social type, which is the real thing, the label, is more balanced, which means that probably the model is not so good after all. So we can compare. We can do a similar plot as this one. This plot used as color map the real thing, right? The real fact, whether it was pictures or videos. Let's see the same plot using prediction for the color map. So using the result of the clustering. Let's see. This is the two clusters. You see, this is not very good. So k-means was not really the tool to use for this data. And I think the reason is probably, well, it's not, these points are not in two close packed groups separate from each other. This is just a series of tails of points starting from 0, 0 onward. So being able to tell them apart is sure possible, but probably k-means is not the best tool. So k-means is more able at finding groups when they are clearly separated. Or maybe one can choose different features other than number of likes and number of comments. Okay, so let's skip this sample usage. You can play with that just for your fun. But the important thing is we created, trained, and basically tested a k-means clustering algorithm. You know, it turns out this was probably not the best algorithm for the data at hand. This happens. This is why usually data science is an iterative process. You have to try several models. In many cases, you have to tune them, maybe automate tuning, automate search for parameters, and again and again until you find a satisfactory result. Okay, so now this is very important for everyone. How do you cleanly close this notebook to save resources for the next one? You see this Spark stop cell here? Okay, Shift Enter. Now the Spark session is closed, resources are being freed, and the final thing, you go to File, Menu, and Close and Halt, where Halt means that you also close, yes,
the notebook.
You also close the underlying server side of the notebook, so the engine keeping the Python runtime running. Okay, so this was the first. I think we are really much running out of time, so maybe we can run, what about random forest as a classification, which is the topic for the homework?
Yeah, I mean, yeah, let's absolutely cover what is needed for the
so
homework.
Let's cover random forest. Of course, you are invited to play with the other ones and also to look in the slides because there is much more information. There are, so naive Bayes is, sorry.
Yeah, what is nice with notebooks is really, you find there are a lot of text. So
Yes.
you see the result and the result are explained as text.
Yeah.
So you can do that.
Notebooks are annotated and every step is described. And also you should cross this information with the slides to get a better idea what's going on. Let me open random forest. This is a classification algorithm. Something weird is happening. Of course.
Yeah.
I see. You know, I know what happened. This happened.
Oh, you hit the timeout of Gitpod?
Yes. So maybe I should resume this again. Okay, which will not work. Because this is stuck here. So now I see the not found error, you know?
Oh, because it was stopping.
Because it will not restart the full stack. It will not restart the Docker Compose stack. But it is still here in the stop state. I wonder what's happening. So now I see where the problem lies for to loop as well. So you have, this is stuck into the stopping state, which is that's nasty. I can't seem to exit stopping state for some reason. Timeout. Open workspace, but it will not work. No, there we are. But
yeah, who knows? So during the time it's starting up, maybe just showing the random forest slide for everyone to explain.
So let's go to random forest, which is here.
Yes, so random forest could be used both for classification and regression. It's based on decision tree. So this is where the forest name came from. So there are some simplified algorithm just to do decision tree that will build those decision tree. As an example, the issue with those three they are overfitted. No, they will work very well with the data set, but then when you run the training set, it's overfitted. So to avoid that overfitted, so the first things, and next slide, the first thing we are doing is splitting the data set. So we are creating something called bootstrapped data set. So we will take a chunk of records and be a subpart of your data set. Then we will only select a subset of the features. So let's say your data set, the data that you have I don't know, a lot of columns. So the columns are called the features. You will design a subset of features randomly picked. And then for each one, so randomly choose dataset bootstrapped, randomly picked the subset of features, and you run the decision tree.
Yeah.
With that, you will get multiple decision tree that you can execute, get multiple results. What you do at the end is aggregate those results, doing an average, just to get the result. So it's called so bootstrap data sets and aggregating is also called bagging. So maybe the demo.
Yeah, so the point is that you get more solid against overfitting by asking a few different trees to do the same task of classification, and then you take the average if it's numbers, or the mode if it's a category label. But the point is to sit on the whole forest instead of a single tree, and every tree is just a bunch of yes/no questions, more or less. So it's an explicit yes/no tree that is created by the algorithm looking at the data and finding the best questions that make you get to a yes/no answer, or whatever it is, the labeling you want to classify. And this is all done by the algorithm, of course. Now, let's see if we manage to make this work. You see, this is now starting again, but I'm sure this is there already, and I just have to do this. That should be enough.
Yeah, Docker Compose up-d.
I think we are good to go with this trick, and that should be it. Okay,
yeah.
So...
Yeah, because even if Gitpod will close your workspace, you still have a state and you can come back and
so it's been, Gitpod stops your machine after some number of minutes, but it will not delete it until 1 week or 2 weeks after it goes dormant. So I was lucky enough to be able to restart just the container that should already have everything ready. Okay, so let's see this random forest algorithm at work. Now, well, I will just gloss over the imports. Again, we are here trying to read the same secrets from the end file for connecting to Cassandra. I'm creating the session to reach the database, and this is actually just as a way to have a look at this table, because there is a table called wines. And guess what? It contains a lot of information over the chemical contents of every wine. There are a few thousands of wines. Each one is has different densities, quantity of sulfur, pH, sugar content, whatever, a bunch of numbers. But we also have a quality, a number from 0 to 10 given by expert wine tasting experts, whatever, like Cedric is, for example.
Yeah, you know, that's blasphemy to me to evaluate the quality of a wine using a machine learning model.
But even just reducing to a number might be tricky. Anyway, for the sake of this algorithm, let's ask ourselves, is it possible to just estimate the quality of a wine by starting from this bunch of numbers? So we will basically try a classification method where the input are all of these features, chemical properties of the wine, and the output would be the quality. Of course, we now have the quality because this is the labeled set for this supervised learning method. But our goal is to have a model, a random forest model, able to estimate this quality without knowing it for new wines, of course. And to do that, again, we will use SparkML. So this is nothing different than before. We are just opening the Spark session and using that to read the Cassandra table called wines, as we saw before. This wine df, this data frame is a Spark data frame representation of the table, and it has this number of rows, so a few more than 5,000 different wines, each one with the quality. So this is just out of our choice. We filter out low quality wines because we want a model focusing on good wines, 6 upward. And we have a new data frame with, of course, you see quality is 6, 6, 6. There are 7, 8, and stuff like that, and all of the features. Now, again, with this vector assembler, I just make it so alcohol, chlorides, citric acid, and so on, instead of being columns, become a single column with a list of numbers. And this column will be called features. Then, okay, let's run it because it's easier to show than to explain. Okay, you see, besides all of these columns, we just have features, which is for every wine, there is a vector containing 12.50035, which is just this number here, collected like this. We also asked the machine learning, the PySpark ML tools to make this quality into a number from 0 upward. So it will basically be quality minus 6. You see 6 here is converted to a 0 in the label. So at the end, the model will be trained with features and label columns, and that's it. And it will be able, hopefully, to guess label given a new features. Every other column was just an intermediate step for the machine learning model. And let's run it. Well, first let's split. Very important point. One of the tools from machine learning tools is random split, which just says, I just get my 6,000 rows split into 80% and 20% in 2 parts that we call train and test, ready to use. So we will train the model with 80% of the rows and use the remaining independent 20% to test how the model performs. And this is where the fitting is done. So you see, I create an object called random forest classifier. This is a machine learning object offered by the PySpark library. You just have to tell it what is the column with the labels, what is the column with the features, and how many trees to place in your forest, how many different trees to create, and how many trees will be asked when it's time to do a prediction to get the average, or in this case, probably the mode. Okay, so with this single line, we ask Spark to do the training in a distributed way. So that could be also over billions of rows in principle, if you have enough machines, which is very cool.
So for the homeworks, you know, not spoiling on anything, but designing how many trees you want, designing what is the subset you want to do would be some parameter you would play with to increase your accuracy and precision.
Absolutely. Okay, so you see, this is where we fit the model, and we directly apply the model to the test dataset. And we get this prediction data frame, and this is it. There are 700 so predictions, and you see, we secretly know the labels of them. So 1, 1, 0, 0, this column here, label, and we can compare it with prediction. Well, this one becomes a 0, so that's not very, very accurate, but let's, okay, this is just the same thing with a bit less clutter. By the way, every predictions come with a list of probabilities associated to each category, 0, 1, 2, and so forth. Luckily, the PySpark libraries also offer facilities to measure metrics. So we want to measure the accuracy, and this we do easily with this ready-made tool. So we can just run this cell. We will use this evaluator object to get the accuracy. The accuracy is 0.74. Okay, whatever it is. That means you remember accuracy. That means more or less that 74% of the cases are guessed right. Maybe in the case of wine, this is the best metric after all. So we do not give a different value to getting too high or too low quality for some reason. That would be the best metrics to use. So there is no a yes-no situation with a lot of no and a small set of yes, like in the cancer example. Okay. So this is the final answer of the model. And here you see how you would use this model. Well, actually over a single line. So that's a bit funny if you want. Because usually if you are using PySpark machine learning tools, you probably want to run it on a very large data set as well, even when you are predicting on your input. But anyway, this is how you would do that. So you would create artificial Spark data frame out of this single row if you want, and just run again model transform as you did with the test case. Okay, so this is the result of running the model after training. Let me close the Spark session to conserve resources and close the notebook. Okay, so I have to confirm exiting. Of course, there are other very interesting models here for you to try out at this point. And I think we can wrap up and go back to the slides for the last part. Or maybe we can directly go to the quiz.
Yeah, I think we can.
I hope you are still connected to Menti. Let me give you the coordinates again. Go to menti.com and enter 25610402. It's in the chat. It's here on this slide, and let me open this Menti. So we are online. Let me do Menti again. Okay. Quiz time. Okay. So please join us again if you didn't already. This time there will be a few questions on what we saw so far. You have to be fast because the fastest get more points, and after you win, you will be given some nice DataStax swag. So get your fingers ready and be correct and fast. Okay, so let's wait for a few more people to join. Maybe I can show the QR code again for joining. Yeah, I see in the chat that sometimes the notebook trouble comes up because Notebook invites you to run in a random order the cells if you want, and sometimes it works. Sometimes it's good with notebooks to be able to go back, change a thing, and rerun a part of the code and all that. But sometimes, you're just tempted to jump ahead, and then you miss a single variable that you had to set, or it's very easy to be taken away by the freedom of notebooks, which might be too much sometimes. Yeah. Okay. Okay, so let's start with the quiz. Okay. What do you think? We start with the quiz? Shall I put some music? Well, let's put some music.
We don't want to be too late, but at the same time, for all the folks that was there with us, the 2 hours, let's wait 1 more minute for everyone to have a chance, or a few seconds. I put back the Menti code, and yeah, okay. So it's 10:08, so let's go.
Okay, so with the quiz. First question. Okay, a lot of people are joining. Okay, so first question. Answer fast to get more points. Apache Cassandra is a fast in-memory database specialized in machine learning. Or maybe it is a distributed computation engine. It is a distributed, highly resilient database, or it is the backend for the notebooks. So what is Apache Cassandra? By the way, look at Menti and not at YouTube for the answers, because YouTube is a few seconds delayed, so you will get not real-time answers. Okay, so correct. 21 people gave it the right answer. It is a highly resilient distributed database. Let's see. Let's have a look at the dashboard, at the leaderboard. Okay, so Earthman seems to be leading.
Was the fastest? Wow, okay.
Yes, okay.
Ted,
so
number 2 and Kevin number 3. All right.
But there are a lot of questions still to go, so let's move forward. Question number 2. Answer fast to get more points. Apache Spark is a fast in-memory database specialized in machine learning. Or maybe it is the distributed computation engine, or it is a distributed database, or it is the backend for your notebooks. You see, same answers, different question. So what is Apache Spark? And your answer is, time's up. Yes, it is a distributed computation engine. 21 right answers again, very good. Let's see. And now the leaderboard is a bit changed, I think. So let's see. Matt, Kevin, and Santiago on top. Okay.
And Bastavora
is
coming in
up.
top
Yes.
10. Great question today.
Yes. Question number 3. Okay, so a labeled data set is used in supervised machine learning, unsupervised machine learning, deep neural networks, or field paleontology.
You were inspired by this question.
Yeah, I like field paleontology, so. Okay, so labeled dataset, supervised machine learning, very good. Yeah, it's not wrong that it can be used for deep neural networks, but of course this is this is a characteristic. This is what distinguishes supervised from unsupervised. So the right answer was supervised machine learning. 30 correct answers, and let's see the timing and whether there are changes in the leaderboard.
Okay, Santiago.
Dalia fastest climbs up and is starting to
look at that. Woohoo!
Close to the 3.
Dala was the fastest this time.
Yeah. So prizes will go to the first 3 at the end of the quiz.
Yes.
And to everyone else, our congratulations anyway. Question number 4. Answer fast. Get points. Okay, so what did we use today? Cassandra, Spark, and PySpark and Django? Or maybe Node.js and React? or PySpark and Jupyter, or maybe COBOL and WebAssembly. Let's see. Did we use COBOL, PySpark and Jupyter? Someone funny answered COBOL and WebAssembly. I can't believe you did it for real. That you must be kidding. Even though COBOL is pretty cool, not only because you can take out the B and get things cool, but also because it is still powering the most important banking infrastructure in the world, I understand. So it's a critical piece of infrastructure what runs on COBOL. Okay, so Virai fastest, but still the first three in the leaderboard are still there. Question number 5. An important step in training is storing the model to file, or the train test data split, or maybe repeating training on different computers. Or when you train, it's better to keep you hydrated, which is important, I have to say. Don't forget the picture of the cyborg in the gym, and train test data split. Very good. Of course, storing the model to file after training is probably what you want to do for using them later. Repeating on different computers is really not so important. Maybe it's more repeating on different random seeds, maybe. But splitting training and testing is by far the most important thing you can do. And most of you gave the right answer, and the leaderboard is Basta Bora is climbing, and still Matt, Kevin, and Talia are leading. And it's time for question number 6. Let's see. Answer fast and correct. Precision versus accuracy.
Oh, wow.
2 terms for the same thing. Or you should always minimize both. And in most cases, focus on accuracy, or in most cases, focus on precision. That's a bit subjective, of course, but choose among the 4 possibilities.
I think we covered it.
Yes,
I think we covered it.
In most cases, focus on precision. Now,
good.
I just want to comment that the second option is really doesn't make sense, because you probably do not want to minimize precision, neither accuracy. Maybe you might want to maximize them, but minimize really does not work. Okay, so yeah, precision in many cases is the preferable metric more than accuracy. Of course, that depends on the model and on your goals, what you want to do with the model, but still, Matt, Santiago, and Viraj now. Very good. But still, I think this last question will make it possible to jump over in the leaderboard, and let's start with the last question. Answer fast. Okay, the output of a model on new input is association, estimation, prediction, or witchcraft. Now, I think the most important here is being fast, because it's probably easy to get the correct answer, but you have to be faster than your opponents. Let's see. And prediction is correct. Witchcraft, nobody did that. Okay, so let's see. Let's see who was the fastest. Abhishek. But that's not enough, and we have a winner, Matt, and Virai and Santiago, second and third. Congratulations to all of you, but in particular, congratulations to Matt, Viraj, and Santiago, who will be receiving their swag. Now, very important thing is, take a screenshot of your screen with the Menti winning screen. Not a screenshot of the YouTube, a screenshot of your own device or tab, whatever, where you are playing, so you can later give that to us and claim your swag. So very important, very, very important. I can give you a link here in the YouTube chat. Maybe I'll keep this open a second. So congratulations to the winners. Take a screenshot and go to this link here, Workshop Swag, fill the form, and we will get in touch with you very soon. Okay, so I hope you took your screenshots, because now I want to move the Menti to this point to collect, and maybe we will leave this open to collect feedback and suggestions for the next workshop or the next time we do this one. I'm sure a suggestion would be trim down some parts and get to the practice.
Yes.
And I agree. In the meantime, quick information about the homework. So the homework is described in details in the README, in the GitHub repository, and there are a bunch of a couple, actually, 4 questions about theory, followed by an assignment. In particular, go back to the random forest and try to make it work better by tweaking some parameters, by looking in the documentation, what parameters are there to choose, and yeah, so you will have a look. If you get stuck, of course, you can get back to us. We are there on Discord, because the YouTube chat is going to disappear very soon. And there we go. So Discord. Please join us on the Discord channel, because this is where the discussion goes on. You see there are channels to speak about various topics, workshops, but not only that, also development and so on. And this is where you will find us later, after this workshop is over.
No, to submit the homework, do you have a Google form? So
Yes.
you will just have to fill some question, do a screenshot, upload the screenshot in the Google form, validate it.
Yes, a lot of time ago we used GitHub for the submissions, but that was a bit not optimal, because you had to give us your email address for us to get back to you, and that was public. So maybe better to have something that is not open to the public, because you might want to keep your email address private. That was one of the reasons.
Also, we can make the form retriable if you miss, because to pass and get the badge, I mean, you need to have 70% of the question right, I think.
Yeah. Okay, so a last point is, we have a YouTube channel. You probably know that, but please subscribe, because we keep publishing and cool new stuff and having new workshops. So you might be interested in what we do. And I think
we will come back to weekly cadence in 2 weeks. So same time, same days on Wednesdays, 2-hour stream covering a lot of topics.
Okay, so there's a question by Aman. At the beginning of the workshop, there was a quiz. Well, it was more a survey to know our audience, with questions such as, what is your experience with Python and stuff like that. So the quiz for the swag was only at the end of the workshop. So this is the one we just had. Okay, I think that's all of it for today. Is there...
Yeah. Keep in touch, ask the question on Discord. Even if you watch the recording right now, we will be happy to answer your question.
Absolutely.
There is no bad question, and all the materials are on GitHub. Hope you enjoy the interactivity. It was a lot of content, maybe too much today, but we are coming back every week, and we will make it better.
Yes, and of course, the material is there in the GitHub repo for you to do all of it by yourself. So all the notebooks are there. You can run them, inspect them, tweak them, play with them. And of course, we are there for answers and discussion on Discord. So please get in touch. And we are looking forward to your homework submissions. We have a bunch of badges here, and we are ready to give them out. I think with that, we are all done. It's 21 past, so it's high time we close. And thank you again for staying with us so far. Enjoy the rest of your day. Bye.
Bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.